All right, hello once again, Jeff Scott of Rankin Technical College, and I've been going over our textbook, starting out with Java from control structures through objects, 6th edition, and we've been looking at the PDF of this book. And what I'd like to do, what I have done so far, is I've gone over the first 7 chapters. And I built several iterations of a payroll program while doing this. All right, Chapter 8, and I'm not going to write a program about Chapter 8, but Chapter 8 is a second look at classes and objects. And here's the things that are discussed in here. But rather than do that, what I've decided to do is to talk a little bit about object-oriented programming in general. So again, there will not be a test, or I'm sorry, there will not be a program for this chapter. All right, now if you do go out online and you go out to wikipedia.org, which is a good site, I'm not going to say it's a great site because at times there are things that are out there that are incorrect. But they've got a big thing on object-oriented programming. Let's just take a quick look at this first paragraph. All right, object-oriented programming, also known as OOP, is a programming paradigm. Now, if you don't know what a paradigm is, it's a shift in thinking. Previous to object-oriented programming, everything was procedural. When you had procedural programming, the data and the methods or functions you used to manipulate the data were basically separate from one another. With object-oriented programming, or OOP, as it says, it's a paradigm based on the concepts of objects, which may contain data in the form of fields, also known as attributes, and code in the form of procedures, often known as methods. So typically your data will be known as attributes. Typically your code to manipulate that data will be known as methods. A feature of objects is that an object's procedures can access and modify the data fields of the object with which they are associated. That's the concept of the this that we've been talking about in Java. In OOP, computer programs are designed by making them out of objects that interact with one another. Okay? So some of the big things regarding object orientation are shown here. Now, the first thing they mention is that, like non-object oriented programming languages, OOP languages have variables and they have procedures, which are now known as methods. But what you do have in object-oriented programming are classes. You already know what classes are. They're blueprints. They're definitions of what objects will look like. Objects are instances of classes. You know that. We started to talk a little bit about the differences between class variables and instance variables. Class variables, if you remember, I made the variable in the last program called employee count, or emp count. That was a class variable because there was just one of them that was shared. So every time we created a new employee object, we upped our count by 1. Instance variables belong to each individual object. So every time we created a new payroll object, they had their own first name, last name, hours worked, and hourly rate, and gross pay. Member variables, it says, refers to both the class and the instance variables, so both of them for a particular class. Not only can you have class methods not only can you have class variables and instance variables, you can have class methods and instance methods. You may or may not remember, but with that print total pay, all right, that really was a class method. All classes, it didn't belong to any particular instance, in other words. An instance method belongs to individual objects. All right. Just a word or two about it is, message passing. It is the responsibility of the object, not the code, to select the procedural code to execute response to a method call. Objects can talk to one another by calling each other's methods, and a method call is also known as message passing. All right. Years ago, I was working at another institution, and I decided that it was time for me to leave that institution and go, well, eventually to where I ended up right now. But before that, I had interviewed at quite a few different colleges, technical colleges, community colleges, etc. And one of the interviews was a phone interview. And they had told me that the hallmark of their program, their information technology or IT programming program, was Java. So they asked me my thoughts about Java. And I mentioned, Java was an object-oriented programming language. It supported things like encapsulation, composition, inheritance, and delegation. Well, stupid me. I know what those mean, but I didn't have a page like this up on the screen when I was going through the interview, and I wish I would have. Not so much because I wanted that job, but because I probably sounded a little bit less informed than I actually am. Encapsulation is basically one of the hallmarks of encapsulation is what I told you when I gave you that definition of object-oriented programming. What did I say? OOP uses public methods to manipulate private data. All right, now that isn't encapsulation total, but in a nutshell, that's a lot of what encapsulation is about. Encapsulation allows for what's referred to as data hiding. And data hiding is a very important concept. All right? And the reason I'm bringing this up is we go through our lives using encapsulation whether we realize it or not. Now, this morning when I got up, got cleaned up, etc., had my breakfast, etc., went out to my car, started up the car, and put the car into reverse. I'm not a mechanical guy, so I'm not sure internally what happened with me putting the car into reverse and the car going backwards. That was hidden from me or encapsulated from me. In much the same way, you see what's on the screen right here. If I do a Control P to print this, all right, I'm not going to, but if I hit the print button, I'm not sure what magic actually happens. Even if I hit cancel, I'm not sure exactly what magic happens to make what happens next happen. It's encapsulated or hidden from me. All right, so they talk about public and private and protected in here, and I've talked about those already. All right, a little bit on object composition. Let's suppose that I were to make an object, and I call that object clock. And I said that the clock had, what would it have for data? Hours, minutes, seconds. I'd be able to get hours, get minutes, get seconds, set hours, set minutes, set seconds, etc. Now later I decide I want to create another class called alarm clock. Well, an alarm clock is a clock. Okay? It's a type of clock. So what I could do this in a lot of ways. I could use inheritance, and I could say that alarm clock extends clock. I could do that. Or I could use composition, where instead of an is-a, it would be more like a contains-a. And so in other words, what I mean is I could have one of the attributes of an alarm clock be a clock. All right? That's composition. So when one object is composed of another object, and maybe other things. Inheritance, virtually all object-oriented classes support inheritance. Inheritance is much like genetic inheritance, but not exactly. You know, I've given this example before. If man with big nose mates with woman with big nose and has child, there's a good chance the child will have a big nose. Doesn't always happen, but typically it does. All right? So what can that child do about it? A, the child can live with a big nose, or B, the child can get a nose job. It's not like the child can grab his or her nose, take it off, and put on one they'd rather have. But that is what you can do with inheritance. It is an is-a relationship. So I can create a class called bank account. And I can say stuff in there that's common to all bank accounts. All bank accounts might have a number, might have a name, might have a person who's got the account, their address, city, state, zip, etc. But then I might create or extend that class to make two other kinds of accounts. Maybe a checking account and a savings account. So checking accounts and savings accounts do have things in common. I could define those in a bank account class. But then I could take anything that was unique to checking accounts and put them in the checking account class. Anything that was unique to savings accounts, put them in the savings account class. Plus anything that was given in a checking account class from a bank account class that I didn't like, I could override it. We've seen a little bit of overriding already with the toString method. Now, Java supports only single inheritance, which means that all child classes can have only one parent. C++ is an example of a language that supports multiple inheritance, but Java does not do that. But Java, like many other languages that support only single inheritance, supports the idea of abstract classes. Abstract classes exist so that they can be used by other classes. In Java, you can have as many abstract classes as you want, whereas you extend for inheritance, you extend a class, you can only extend one class in Java. You can implement as many, well, actually I'm getting ahead, that's interfaces. But abstract classes, look at it this way. If I told somebody, hey, guess what? I went to the pet store last week and I bought a pet. Well, chances are pretty good somebody's going to ask me, well, what kind of pet was it? So I could have I could create an abstract class called pet that I'm never going to create. I'm never going to instantiate or create an object of. But I'd use this as I'm making an class hierarchy. And then under that pet class, I could have dog, cat, fish, parakeet, gerbil, ferret, etc. So the person says, oh, what'd you do? I bought a pet. What kind of pet? I bought a dog. What kind of dog? So dog might also be an abstract class. So classes that you create without the idea of instantiating them are known as abstract classes. But then underneath pet and underneath dog, I might have Saint Bernard, Golden Retriever, Beagle, etc. So if I say I bought a Bichon Frise, which is what my wife bought, all right, that would be a concrete class. All right. A couple more things here. Polymorphism. Well, I mentioned a bunch of different pets before. So let's talk about 5 pets. A dog, a cat, a bird, let's just keep it at that. A dog, a cat, and a bird. All right? If I write a method that's called speak, and I do speak for a dog, the dog is going to say bow wow, roof roof, woof, whatever sound a dog makes. If I say it for a cat, it might purr, it might meow, etc. If I do a bird, unless it's a parakeet, or something like that talks, it might just tweet. The point is, if I call the speak method for any of those 3 types of pets, the right sound will come out because the speak method will be associated with the right class. That's polymorphism. I think that's about enough from here. So get rid of that. And in fact, the other thing I had was this. What are characteristics of an object-oriented language? This is just a page long. Emphasis on data rather than procedures. Data is equal in stature to the procedures that manipulate it. Programs are divided into entities known as objects. Data structures are designed that characterize these objects. Functions or methods are tied together in these data structures. Data is hidden and cannot be accessed by external functions. Very important two terms here, and those are interface versus implementation. All right, so if I come out and I do this, I go to calculator. Some of you have seen me do this before, and I type in 891, and I click the square root button. I have absolutely no idea what happened internally to convert that 891 into its square root, which is 29.849, etc. And I don't care. My interface when I come in is this. This is my interface. That's what I'm shown. When I type in this number, I'm still using the interface. When I click this, I still see the interface. The implementation is what happens behind the scenes to turn my 891 square root into 29.8496231, etc. All right. The good news is when I use an object-oriented programming language, if somebody came up with a brand new way to create square roots that was faster than the way that I'm doing it here, which is pretty doggone fast, all right, as long as my interface didn't change, I could change the implementation. And that's the big thing about data being hidden. Objects communicate through their methods, message passing like we talked about before. New data and functions can be added as necessary. It follows a bottom-up design and programming. All right, so it goes from the very specific to the very general, as opposed to vice versa. The characteristics, class definitions. Classes are basic building blocks. They're blueprints, as I said. Objects are instances of a class. Abstraction we talked about. When you abstract something, you tell it what to do, but not how to do it. Kind of like the difference between a little kid and a teenager. If I'm a little kid, or let's say I'm a parent of a little kid, and let's suppose that I want to show them how to, I don't know, do origami. I might have to show a little kid a lot as far as what to do. Whereas if it's an older kid who maybe has some practice doing different things with paper, etc., I might tell them what they have to do, but not show them how to do it. Encapsulation we already mentioned, binding data and the operations that act on it as a unit. Inheritance we went over. I just talked a little bit about an object or a class hierarchy. Polymorphism we just looked at. Multiple definitions for the same name. I used the speak method. When you build enough classes, you tend to end up having or create a class library. All right. Finally, we talked about message passing. I think that's enough. So what I'm going to do, I'm just going to save this and I'm going to call it OOP. Yeah, we'll leave a name on it that I gave. All right. I'm going to come in now and I'm going to create a program for Chapter 9, which is our next chapter. But it's not going to be, it's going to totally break away from the idea of using payroll systems. And I'm going to create a program that lets you put in a string and see whether or not it's a palindrome, whether or not it's the same forwards and backwards. So that's what I'm going to do next, and I'll be back with that very shortly.